Here's number 32 from the book. They want us to identify what type of conic it is and then sketch it and find a whole bunch of stuff out about it. So notice this is not quite in the form that we have been working with them because there's a 3 here instead of a 1. So I can do this. To draw the graph, I don't need to do this, but to identify the type of conic I'm going to do is I'm going to divide top and bottom by 3 so that I get that to be a 1. So this looks like a 10/3 on the top, and the 3 divided by 3 is 1, and then the 2 divided by 3 is 2/3 sine theta. So I'm looking at that 2/3 right there and seeing that E is 2/3. So that is going to be smaller than 1, so we're talking ellipse. Okay. So that being said, I'm really going to focus on this thing to figure out what the graph looks like. So the first thing I do is I don't graph it in polar coordinates. I graph it in what would be just regular rectangular coordinates. And again, I focus on the denominator first. This is the amplitude 2, actually upside down, amplitude 2 sine curve shifted up 3. So 3 would be in the middle here. You go down 2 to 1, you go up 2 to 5, and it's an upside down sine curve. Right? So I can see at the various spots here, this is pi over 2, this is pi, 3 pi over 2, and 2 pi, where my nice points are. So now what I really want to do is I want to take the reciprocal of that. So taking reciprocals now, the reciprocal, the smallest reciprocal is going to, the smallest number is going to give me the biggest reciprocal. So 1 is as small as this gets. So the reciprocal of 1 is 1. That's as big as this is going to get. The reciprocal of 3 would be 1/3, which would be about right here. And the reciprocal of the top here, this would be 5, would be 1/5, so that would be even smaller down here, 1/5. So it's going to start at 1/3, it's going to go up to 1, it's going to come back to 1/3, it's going to go down to 1/5, and then back to 1/3, so you can see this thing like that, okay? Now, I actually need 10 times that. So what I need is, well, just multiply everything by 10 here. So this instead of 1, this is a 10. This is a 10/3 and 10/5. Well, 10/5 is 2. Okay. So now I can actually draw it in polar coordinates because I can see that in the direction, this is theta versus r, right? In the direction of 0, I'm at 10/3. That's what, 3 1/3? 3, 4, so I'd be right in there somewhere. In the direction of pi over 2, I'm out at 10. So straight up here, I'm up at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. By the time I get to pi was right there. So by the time I get to pi, I'm back to 3 1/3 again. So back to here. By the time I'm at 3 pi over 2, so looking straight down, I'm at 2 10/5, right? And I can see that I've got this ellipse here that's going to get those points, right? This thing never crossed 0, so I didn't have any asymptotes there. We're not creating a hyperbola, we're just doing an ellipse. That we start off at this radius, it gets bigger and bigger and bigger and bigger, and so on. And then it gets smaller again, back down to as low as 2, and then back up there. So I've got this ellipse. Okay. Now let's label some stuff on here. There's things I can see without doing much more work. I know where this vertex is, right? There's a vertex here at what's that? 0, -2. Right? That was when I was at this lowest point right there. I see another vertex up the top here. Why did I get a T in front here? Let's call that a vertex. Well, that's up at 10, so that would be 0, 10. The foci are also particularly nice because the foci happen, one of them is right at the origin. Always the case with these polar conics. That's a focus right here at 0, 0. The other focus is this, whatever this distance is, it's the same distance away from the other vertex. So if this was distance 2 right here, and that's going to be a distance 2, so that focus has to be at 0, 8. Right? Now, also I can see where the center is, because halfway between the 0 and the 8 there must be at 1, 2, 3, 4. This spot right here must be the center at 0, 4. All this stuff I get, I can find out about this conic just because I figure out where all these points are. Okay. One other thing I might want to know is I might want to know the book doesn't actually ask for it in this problem, but I want to find out this, what would be the semi-minor axis. I can see the semi-major axis here is the distance from the center out to the edge. So from 4 to 10 is 6. I'm going to call that A, right? So I can see that A is equal to 6. B is the semi-minor axis that I don't know what it is. And the focal length here is the distance from the center out to the focus, and that's usually we call that C. So C is equal to 4 in this case. Right? Now there's a relationship within ellipses here that this diagonal distance from the focus out to that spot over there, the end of the semi-minor axis, that's the same length as this distance from here. That has to do with creating an ellipse by using a string. You can see that that's the same. So anyway, I know that a squared equals b squared plus c squared in this thing. So I've got a is 6, 36 equals b squared plus c squared, which is 16, which tells me that b is the square root of 20. Which is 4 times 5, yeah, so 2 times the square root of 5. Right? So I can figure out where that point is there. It's 2 times the square root of 5, comma, what was that up at 4? And then, of course, that other point would be at negative. Right? 2 times the square root of 5, comma, 4. Anyway, there's all kinds of information about that ellipse with the polar equation given there. Notice I never turned it into x squared over a squared plus y squared over b squared equals 1 or anything like that. I didn't need to do the conversion into turn the equation into x's and y's. I can just draw the graph from the information about polar coordinates and get all the information about that ellipse from them. So there you go, number 32.